Poor Johnny. Your internet is giving you so much trouble today.
I hate it so much.
It's fine. Everything's wonderful. Nothing's terrible. What is this? The points are made up and the rules don't matter. Something like that. I don't
That's
know.
right. That's
That's
right.
the one. So welcome, GitOpsians. Hello. We are, let me see. I'm struggling to think if I have announcements today because I got distracted by Johnny's Wi-Fi. Announcements today. Johnny's Wi-Fi is on the fritz. um, he may or may not end up largely decorative, and if he ends up decorative, it's because it froze. So that's okay. It happens to the best of us. At least, Johnny, at least you can say you were a decoration today.
That's at least something positive comes out of it, right?
Yes, absolutely.
Oh, he was right then.
Yes.
Yeah.
That could not have been more perfect.
Yep. At least the universe has karma.
Yeah.
In positive ways for him.
Yes.
That's great.
That was great. No notes. Exactly zero notes.
We planned this.
We did. I sent a little ARP storm his way. No, I didn't. Anyway. God, I hope it's not an ARP storm. That would be terrible for you.
Yeah, I have no idea. So
anyway, announcements, none are coming to mind. I got no announcements right now. So we'll skip straight to guest introductions, which for me is this way. We are joined by my personal friend Angela Thomas today, and I asked Angela to come on because she's got a very interesting background delivering applications on real hardware and desktops and stuff, things that I haven't really done a whole lot of, and I think is really interesting. And I was like, man, who can we nerd out about this stuff with? And then I was like, oh, I know who. So that was how she got roped into this. It's this thankless gig. So if I am assuming on behalf of everybody that you're giving her a warm welcome, and then Angela, I'll let you introduce yourself a little further.
Sure, yeah. My name's Angela. I have been doing development for quite a while now, about 16 years or so. I started off my career by doing a hardware engineering degree, so that's like ASIC chipset design and lithography for integrated circuits and that sort of thing. It's sort of like a cross between electrical engineering and computer science. A little bit less emphasis on the algorithms than in computer science, but due to the electrical engineering and the hardware side of things, a lot more emphasis on maintainability, risk management, good architecture, and that sort of thing, which makes sense if you think about hardware, right? That's a release it once, and then you don't really get to update your hardware in the field very often. So that was the degree that I did, but in my career I focused a lot more on software, and then last year I stepped into a management role. So as a developer, most of my work was on small teams, client server networking things, full stack, but old school full stack. And so by that I mean, like Hillary's saying, desktop applications, right? So like front end to the back end on the same team, but the front end was a desktop application installed on a Mac OS or Windows or Linux, and then the server was like a Linux hosted server or Windows server or a bunch of different things like that. So full stack, but old school full stack. And so I'm really excited to be here to talk about this because I think it's actually becoming more relevant again. It's one of those like all fashion comes again around again, all tech comes around again. There's companies now that are looking at doing cloud repatriation efforts.
Mm-hmm.
They're basically realizing like actually it's expensive to run your email in the cloud for some sizes of organizations, or expensive to run insert service here on the cloud with subscription services. We've grown from a small company to a big company, and now we want to host this on site. So some people also call that reverse cloud migration is another way that I've heard that described. But oddly, I think there's going to be more people doing desktop application development and testing in the near future.
Yeah.
I
was gonna say, I don't know if you saw several weeks ago, actually a few months ago now, we actually had the IBM Z Systems, which is the mainframe group. Mm-hmm. So part of their group came on, they work with Ansible, and they do like Ansible playbooks for mainframes. And kind of like similar to what you're talking about, like kind of the reverse migration, we're actually seeing like hybrid cloud architectures, right?
Yeah.
And that's like a really, really big thing. I think like we've published like some white papers on the hybrid cloud architecture, and like so hybrid like mainframe cloud architecture as well is like a whole thing. So extremely relevant to, like you said, the times, your background. So I'm really excited about this. And I think You told us something earlier about like where you live that was really interesting, and you're
Uh,
not getting out of saying that to the rest of the
No.
audience here.
So you may be able to tell by my accent that I'm a Canadian. I'm one of those people, and I live in the part of Canada that's like along the Rocky Mountains, but also kind of prairies. It's a little city called Calgary. We're about 1.5 million people, which in the U.S. is small potatoes. That's a nothing burger, from what I understand. But in Canada, we're the fourth largest urban center, so we're small up here. But yeah, we used to tell people that we're where the Olympics was in 1988, and nobody remembers that anymore because that was a billion years ago. But our claim to fame now is that we were where most of HBO's The Last of Us was filmed. Calgary, the surrounding areas, Banff and Canmore, beautiful places out in the mountain, and then our capital city of Edmonton here. So if you enjoyed all of that desolate, apocalyptic, barren wasteland of frozen beauty, it's technically not winter here yet. So don't come here now if you want to see that. Come here in 2 months and freeze. But yeah, no, it's gorgeous here, and it's weird to be in a place that people film things, because if you grow up in that sort of thing, you kind of take it for granted. I think there's a few other shows that film here. Fargo, if you've seen it. Fraggle Rock, although that doesn't really highlight the scenery. That's a puppet show. But yeah, we have a film industry here. So yeah, I'm not part of it. I just appreciate it. So yeah.
That's fantastic.
Zombies.
Yeah, they do. They do the occasional commercial in my neighborhood, not on my street, because my street is like on the top of the hill and lacks some of it. But there are some streets in my neighborhood. I think it was like Lexus did one recently. There's some streets in my neighborhood that are beautiful, tree lined, like very like that kind of a look. And so they'll film on those streets, and then it's hilarious because I live in the city of Oakland, California, where they haven't repaved some of these roads in 50 years. So like you can't go, like they'll find like the one street that looks like good, and then like film from pothole to pothole on that street so that you can't see that the street isn't kept. That actually happens. It's sad but true, and kind of like gallows humor, funny, really.
Dark humor. I'm with you.
Funny. Yep.
It's why we're friends. We share a dark sense of humor.
It's true though.
Yeah, for the Last of Us, there's parts of it that I don't know how they would have filmed if it hadn't been the pandemic. I think it was the first episode, one of the first episodes anyway, where Joel and Ellie are like walking on this bridge full of cars, looking over a city. That's one of the major thoroughfares in our city into our downtown core, and like everybody works in downtown. So, had it been regular life, not the pandemic and everything closed, they would not have been able to shut it down for however many days they shut it down for. Days though. It's stop and go traffic, morning and night, and so yeah, it'll be interesting to see. I don't think they're going to film the second season here for a variety of reasons, but yeah. Anyway, if you love The Last of Us, the landscape at least is where I'm from.
I like that. I'm from the landscape. Yes. Yeah. That is amazing. Okay, so let's go ahead and start like actually
talking about the
things. We could sit here and just be ourselves for an hour, and I'm sure that would be very interesting, but it is not exactly what is on the schedule. So yeah, Jonny's got to go off into the background because he's feeling the misery of Wi-Fi not liking him. What is it? Hug ops to Jonny's Wi-Fi. Yeah, there you go. That's the
hug ops.
Hug ops.
I'm writing that down.
It's like an SRE thing, like hug ops to whoever has to deal with the reliability of that thing that's down right now. Anyway, yep. I don't remember who I got that from, but it definitely is something I picked up from within Red Hat, and I don't know where it came from originally. So not taking credit for it. Also don't know who to attribute credit to. So if it was you, at me, and I'll give you your credit in post. So yeah, let's talk about our actual topic today, which was what was it? Software quality and delivery of software off the cloud.
Mm-hmm. Yeah. So I think the first thing we wanted to just talk about was CICD and just what that looks like. So, the CI, the continuous integration side, CD, continuous deployment, or in desktop, we often say continuous delivery because you're not necessarily deploying it. It's more delivering it to internal customers, let's say, other developers or testers or things like that. But I think we were all familiar with that sort of DevOps or CICD infinity symbol, like the build, code, plan, release, deploy, test, that little infinity symbol. And it's not actually that much different on desktop with installed applications. It's just that you're not deploying live, you're deploying to a test staging area perhaps, or you're putting an artifact in your your server so that the QA folks can download it, or another dev team in the building can pull that down. So sorry, and I say in the building, that's just because not only am I old school with my tech stack, but I've worked in a lot of offices with a single office, small little companies. So if I say in the building, I mean in the organization. But yeah, so that's really, like, it's not that much different. But one of the biggest things that is different is that, and this is going to sound one of those like obvious and hindsight sort of things, but there's installers, and your installers are a piece of your software package that gets delivered to your end users, or not your end users, but to the customer, right? And so sysadmins are your friends, and you need to make sure that they like you and keep you as friends, because if they don't like your installer, if it doesn't have a command line interface, if it doesn't let them blast your application across the organization exactly how they want, like they just want it sent to the engineering team, or the sales team only needs this, or this team needs the fancy license and this team needs the low end license. You need to be able to accommodate all of that, because if they can't install it easily, they are not going to like your tool. And so it doesn't matter how many people in the organization are clamoring for a tool. If it's garbage to install, the sysadmins are going to really, really push back and try to find something else. And I speak from family experience. My father was a sysadmin for a very long time. He's happily retired now and just rides his motorcycle everywhere these days. But we would have lots of discussions about horrific installers, and why a GUI installer one at a time on every desktop is the last thing he wanted to see.
No,
Yeah.
no, that's bad. I like how top comment here, -- silent -- install, right? Like, yes,
Yeah.
give
Yep.
me that.
Yep.
That's what I want.
Yep. Yeah, and then the flip side of that too is, obviously, if you have an installer, you need to have an uninstaller, and your uninstall needs to leave the system the way it was before you got there. And that's another one of those things where, when you're running your own, when you're pushing your stuff to your own cloud, who cares? Leave it a mess if you want. Nobody gets to see it. You can clean that up later, right? But if you're uninstalling off of a user's desktop machine, or if they're doing a server install for some sort of hosted on-premise server product, and you leave, if it's a Windows server or Windows desktop, and you leave the registry littered with garbage, on Mac, it's plist, and on Linux, stuffing things in bin or opt or wherever you feel like. Leaving things lying around does not endear you to anyone, and it's not good practice. So there's definitely some best practices around installers. We don't really need to get into all of that, but it is one of the biggest differences, is that you do have to make your installers usable and user friendly. And sometimes you have to think about the sysadmins, and sometimes maybe there is going to be somebody doing a one-off install that does want a fancy, nice, pretty GUI tool that lets them choose all the same options that the sysadmin will want to. So yeah, I think that's probably like the biggest difference. But we can then talk through some more of the the challenges through desktop that are a little bit different, I guess. Did you have anything that you wanted to add, Hilliary, about installers, or about the continuous deployment aspect being less?
No, I don't think so. It's funny because for OpenShift, right, which is obviously a thing that I work on all the time, we do have an installer, and I was just thinking, like, you can't uninstall it, and you just kind of delete everything. I guess I don't.
But you have to actually do that.
Yeah, you have to actually do it. I'm saying this. Somebody who's actually uninstalled. Yeah. There's an install destroy. Yeah, that's it. That's the command. Jonny sent me the command. It's a OpenShift - install destroy cluster -- dir. That'll do it. To be honest with you, what we end up seeing more often, because I don't support OpenShift like in on-prem, like on hardware.
Mm-hmm.
I do it in the cloud. What we realistically see more often is people just kind of like nuke whatever's in the cloud.
Yeah, well, and you're spinning up images, so who cares,
Yeah,
right?
so who
Nuke
cares,
the image,
yeah.
spin up a new one. If it's their depending on the IT organization, if it's a small little company with like 20 people and they're trying to host their own whatever email VoIP server, whatever it is. I worked on a VoIP product for a while, like a video thing. Um, you can't blow away the whole server because they might have other things on there. And
Yeah.
should they probably? No, they probably should have them all isolated. Do they always?
No,
Not always. So
not
being
smart.
very nice and only cleaning up what you're allowed to, very important.
Yeah, very important. Yeah. That reminds me of an anecdote about one time I took down production by testing very well in staging, because as it turned out, the databases shared a VM.
Oof.
And I
tested really well.
I tested really well.
Yeah. Chaos engineering.
I did the thing. Yeah. Maybe did we talk about that on the last stream, or did we talk about that in our prep call for this stream? I don't remember. I think I told you this story already, though.
It's a good one either way.
It's a great one. But yeah, that whole segmentation. I said the cloud has allowed that to happen. That, a lot of things in the cloud these days feel like ClickOps. I think Christian said that several weeks ago, right? It's kind of like a lot of ClickOps. That's definitely true. I definitely see that firsthand. There's definitely an elegance to the ability to do something in a repeatable way at like extreme scale, like what you're talking about. Like I need to put this one thing on 1,000 computers, right?
Yeah.
And being able to do that delivery from like a central location onto the machines, because the machines are managed by something, etc. And man, that stuff gets wild. But yeah, I don't think I have any additional. I don't think I've got any questions on that. It's if you've ever had a computer managed by your organization, you've seen a little bit of this stuff firsthand. I feel like everybody's probably experienced that more or less. If you haven't experienced that, where do you work? That's what I want to know.
Yeah. And like really, it's you're saying it gets kind of wild pushing it out to thousands of computers or whatever, but at the same time pushing it out to thousands of images on a cloud, like it's the same, but it's different, right? It's like the book version of the movie.
Yeah.
Right? Like it's the exact same thing, and it's completely different, and it's exactly so like the issues of scale, you need to be able to test that, just like you need to be able to test at scale, for cloud deployments across multiple images. You need to be able to test what happens if it fails in the middle. Do you actually get a reasonable warning? Hey, these 6 computers didn't actually finish their update of this software, or they didn't get the new rollout. The installer failed for whatever reason. Do you just get told 6 computers? Do you get told, this computer had this problem, that computer had that problem? It's all of those, the implementation details that are really where the rubber meets the road. But it's push come to shove, you squint hard enough, and it's like it's like C++ and Java. Like, it's the same. It's not, but it is.
It's not, but
don't go the other way. Don't go the other way, but it's not, but it is. And I think that's also just part of like working with a team that has experience too. There's, if you work with a team that has experience, somebody on the team has probably seen something sometime and is able to make the mental leap to say like, you know what, this is probably pretty similar to the thing that I did before. Let's try to handle it this way. So,
yeah.
Yep. Yeah. So beyond just the installers, then talking about doing updates and how maybe an update is going to fail where the sysadmin or whoever it is in your organization is doing the upgrade. Keeping track of the versions that you have in the field can be really important with desktop applications, whether you are doing an on-premise server or if it's just like a Microsoft Word equivalent or something like that, which I guess is cloud hosted now, but you know what I mean. Keeping track of your versions is important, but also deciding how many versions historically to support. So if you know that a large portion of your customer base is still on 3 versions ago, there's a bug, or that you've done some testing and it doesn't work on new operating system that's coming out, then you're going to have to contact them and let them know that like, hey, we've done some testing with the version that you have that we've got a support contract for. You're not going to be able to use that because of this, or that particular feature is going to be buggy or not available when you upgrade your operating system because insert reason here. And so it's knowing the versions you have in the field comes in handy to be able to make that contact those customers proactively. But then, having to do that test, having to keep that test matrix around, having to remember that you've told that customer, yes, we're going to give you 10 years support on this hardware. That means that you got to keep testing that for that whole time. And so the test burden, I think, can be a lot higher, just because you're going to not just have the current version to support. I guess in the cloud, there's a very high test burden to make sure that it works on lots of different networking environments, like Johnny's internet example today as, a exact point of that. All the different browsers that are out there, whether or not back when we had, other technologies powering the internet, let's just say, that you know as those technologies come and go, it's a very fast cycle with the web, right? Every 2 years, basically, you throw out your tech stack. Not exactly, but it's a lot slower with desktop, and so you're gonna need to support things for longer and manage that. That's something you really have to manage, or you don't, and then your customers hate you and you give them steep discounts to upgrade to the newest thing, and then you're not actually making any profit. So you can always bribe people with something that's cheap. You can give them a discount. You can say, oh, we're going to be a free upgrade, to try to move them forwards. But also, some companies just won't, or they don't have time, or they say they're going to and then they never do. And you can't go and force them to. So it's very hands off. But if you do have support contracts, it behooves you to be a bit proactive on some things.
On the so I've done mobile application development a few times, right? Or rather, I've done the quality engineering for mobile application development. Let's be really clear here, because I don't want to make it seem like I wrote the features and then some of my old colleagues were like, you didn't do any single line of code in this application. Like, we'll be very precise, even though I don't think anybody I've ever worked with is that petty. Although I could see them giving me a little bit of grief for it just for the giggles. That sounds like them. That sounds like a lot of them. But anyway, so with the paradigm of the mobile application, right, you actually have a lot of that same problem of like huge hardware sets, versions, people don't upgrade, people will not upgrade their phone application or their phone operating system, etc. But at the end of the day, now people are buying a new phone every couple of years because it's just you kind of have to, because of the rate that it moves. That even with all of those problems, you're still not seeing 10-year cycles, right? I don't think I could turn on a phone. I don't think I have a phone to turn on that is 10 years old, first of all. But I don't think I could turn on a smartphone that's 10 years old and have reasonable expectations that it would be able to function with anything that's not just completely local loop. That said, though, what was I going to say? I lost it. It'll come back to me at the worst time.
Yeah, I think it was just that, like, it's, again, same but different, right? Like, it's the same. Like, you gotta keep testing all of these different things. How many different cell phones are there out there, and how many different browsers, and they didn't upgrade. It does work on this one. It doesn't work on that one. It's the same, but it's different. It's just the exact same set of challenges, just with a different coat of paint on it.
Yeah, coat of paint. Sometimes a different, just like the time loop really is what I wanted to go as. The time loop can be shorter, which actually, because of how frequently, like with a desktop application, like how often are customers expecting updates to that versus how often do I expect my mobile application to get updated, right? It's a hugely different time loop. I think like one of the longest like cloud like support, like guaranteed support periods on versions that I hear of day to day, not that it's the longest I've ever heard of, but that I hear of day to day, is 18 months.
Wow, that sounds amazing.
It's so short.
Why have I ever done desktop?
So short, right? I like, what if it's like,
you can't support that for 10 years. It would be impossible.
It would be. Although, and then you get into mainframes where they've been doing it for more than 10 years because of that whole situation. Yeah. Mainframes are fun. I want to grow up someday and work on mainframes is really the takeaway here. Like, that'll be my ultimate, like, nerd girl upgrade is I'll get to go work on mainframes someday.
Yeah. I mean, I think that the entire computer industry is fascinating all over the place. I could live to be 5,000 years old and I would never be bored. Like, teach me everything. I want to learn more. And then by the time you've learned everything, everything's different.
It's all different. It's every few years there's something brand new. I was just having a conversation today about this thing that we're doing and it's rolling out. And there's kind of wait, why did we do this instead of this other thing? Well, that other thing wasn't there.
Right. Yeah.
It wasn't there.
Didn't exist. Like,
So you can't just start over just because 6 months into a project something slightly better comes along, right? That's I
yeah.
always say, choose your technical debt wisely. This goes
Yes, I
into it.
love that.
This goes into it, right?
Yeah. Yeah, I mean, I took a machine learning neural network fuzzy logic class in university a long time ago, let's just say, and it's useless now. It was cool, it was neat to do it, but the lithography class that I took, like, we're not even using the same nanometer wafers anymore. Like, it's different, but also it's the same, right? Everything is
Those
different.
were all words.
Oh, true. Yes. You said
Nanometer wafers. Those were all words. I don't know what that means.
we could talk about. I'm sure you can find someone much more qualified to talk about CPUs and wafer. But anyway, yeah. And back to desktop applications and the life cycle of them. I don't work in healthcare. I know people that do work in healthcare in my province. I don't know if this is the same in the U.S. in government and healthcare things, but I was told that they were still working on Windows 7 and that they were struggling to even just adopt modern development practices, or not development practices, but like modern practices to run the hospital and pulling in interesting new products to use, because nobody is developing for Windows 7, but they have critical things for their infrastructure that they use as part of patient care that only exists on old ass stuff. Old things. And
Don't worry, the FCC doesn't look at this.
yeah, I have a bit of a potty mouth sometimes. Definitely is because I'm Canadian.
I was going to say engineering. That sounds like an engineering problem.
True. But yeah, it's not just about keeping, like, as an organization, you deciding what you want to have as that window of support. Depending on the industry you're serving, sometimes the industry tells you, and they can tell you some pretty crazy things from what I've heard. I hope to God I never have to go back and do Windows 7 development. That sounds not fun, but like, everything's in cycles, so who knows? We'll see. I don't want to.
Yeah.
We'll see how the future goes. But
They're
yeah,
going to put it in a container, and then you're going to have container images with Windows 7, and then you're going to have to port those desktop applications that don't have an update to work on those Windows 7 containers. Like, that could happen. I wouldn't put it past this industry to do it. It's one of those, like, you could do it. Should you do it? Probably not. Will we do it? We do a lot of things we shouldn't do.
The good thing about living in Canada is our beer is very, very strong. So
excellent. Yes,
it does help. Anyway, yeah. And then, and along with talking about your application versions, right? And we're saying that this version of your application is going to be something you have to maintain. You also have to start thinking about your file version. So if you are, if you're not just dealing with PDFs and text files, if you have your own proprietary file type, you're going to need to decide when you want to upgrade that and what version you're going to have of that, and then how many versions back in your file reader and writer you're going to support. Maybe you don't support writing to older versions. You say, if you're using the new version, you import it, you read in your old one, you save it out. Those are things you can do, but these are all decisions you have to make, and then you have to support them, right? And you have to keep weird files. Your customer will send you a file and say, this crashes, this version of this app. And you're like, that doesn't make any sense. You look at the file, nothing looks like it should crash. Load it up, crashes every time. So you end up having weird things that you have to store as test artifacts in places, just because, what they say about video games and is very true about software. This may be some sort of quote in cloud things as well. You're welcome to tell me, but like, the number of people that will test your application the first day that it's out there, or your video game on launch day, there's no way you can do that amount of testing before you launch. It's an impossible, especially when you're talking about individual PCs and like, I have a friend who did a bunch of desktop application in different industry for a while than I've worked in, and he said that they had this massive test lab with just so many combinations of graphics cards, hard drives, all of this stuff. And if somebody said, we've got this configuration and the software crashed, they would go and pull things out of different machines to then be able to build something that looked the same, to be able to test it. And this is just what happens sometimes. So yeah, file versions, keeping around really huge files, and just like you would do testing a proprietary file format in the cloud, right? Just you got to remember that for desktop. There's going to be weird files, there's going to be big files, and there's going to be big and weird files. think about the size, the maximum size of a file that you want to load, and then that's going to impact the hardware requirements that you're going to set for your application. Because if you want somebody to be able to load a file that's 8 gigs of reservoir engineering data that models what a hole in the ground looks like, to very precise decimal places, you're not going to be able to do that if they only have 2 gigs of RAM, right? So it's all of these little things that kind of add up to big decisions that you have to make about your product, and that you can't fix, right? You get to tell your customers this is what our minimum is, and if they say, oh, we don't have computers like that, we're not buying your software, then maybe you don't know your customers very well. So yeah, lots of things to keep track of, just with the state of hardware in the industry, both all the new stuff coming in for whiz bang fancy graphics development software, but then also the older things that your customers might be using. So really keeping that top of mind is helpful.
Yeah, and I think, I don't know about what you've seen, but like I know people who work at or run like really, really tiny shoestring budget nonprofits. And yeah, they would love some of the things that are designed to help make nonprofits like easier, but doesn't really work out so well actually when you're talking about, just older, the fact that they're working on older computers. So if you have even like some very flashy SaaS in the cloud, well, older computers are not going to have the processing power necessarily for the browsers to do that in a in a timely manner. So they might end up seeing something like 45-second page loads. So even in the cloud, you actually really need to start. People don't, because it's like, oh, we just get a newer computer, and like that's fair. But like it is one of those things to kind of be aware of. That is, as much as you can possibly optimize your stuff for the lowest bar, lowest baseline, like this would be like the worst thing we expect to see, and like optimize for that. I always advocate for that approach to thing. Like how lightweight can we make this? How small can we make this? Could I run this off of a Raspberry Pi? Right? I ask myself this question all the time. Could I run this off of a Raspberry Pi? And I like to approach to as much of a degree as is reasonable. I like to try to approach software design from that perspective as well, because that way it kind of creates a bit of an equalizing factor on things, which is not always 100% possible. Like you said, you're not going to get models that do like help people understand how deep to dig the holes down to the centimeter, right? You're not going to be running those off of a Raspberry Pi, or you could run them with distributed computing off of like a million Raspberry Pis, I guess. Like that can work. That's a thing, but probably not realistically.
Yeah, that industry basically uses the same sort of things that they use to render movies. Like it's a rendering machine. So if you're gonna ask somebody to be able to run that software on just like bare basic Chromebook, not gonna happen.
No.
Yeah, and like the size of things also comes down to the installers. The video voice and video product I was on back in 2007, which was a while ago. It's a funny story. The CTO of the company eventually canceled the product because he decided that video over the internet was not going to be a big deal. So my coworkers and I always like to joke about how, remember the time like in 2007 where we were told not to make Zoom? That was such a great call. But yeah, anyway, yeah. So it was good times. But yeah, that product, the client. So we had a server. You would install it locally at the company, in your firewalls, behind all your security and whatever, your VPNs and whatnot. And the client was just, you'd hit a page on the browser. They would have it redirect to the server, and it would auto download the executable, do all the install and everything like that. But afterwards, you choose your language, whatever else. The actual thing that would sit on your desktop, the company president had a very, very strict idea of the size that he wanted that to be, because he wanted it to be able to run on computers that didn't have a lot of space, on computers that maybe weren't the greatest. And so, yeah, there was actually a point where we just had a virtual machine that had almost no anything that we would always just do a test on, just to make sure, like, hey, does it still load on the basic box in the back? Let's make sure that still is cool, because yeah, he just, for whatever reason, that was something that he really wanted us to focus on. I don't think we had any users that had such restrictive such restrictive computing, but it became a challenge because, you know, we had audio and video codecs that we used that we didn't write ourselves. And as
Oh,
those
which
grew,
codec did you use?
I don't remember what codec it was. That was a great sound I just made. I don't remember what codec it was, but I do remember we were mostly focused on desktop sharing, not the webcams, because 2007 webcams sucked. Um, there's a lot of suckitude in webcams at that point, and so we were using for desktop sharing. We had our own proprietary algorithm, but for video, I read this big like 3-inch textbook on H.264 because we were going to upgrade to that from 4sif. So if you want to go read about 4sif, the reason why you haven't heard of it is because no.
So way
Potato
back around okay, so 2009, I was
Sure.
working at a company, and some of the engineers that worked at the company had all come from a different company where they had done video streaming of a certain nature. Um, and the video codec they used for that was the I think it's the OGG codec.
Oh yeah, OGG, yeah.
And the actual developer, and I'm still friends with him, by the way, so hi Rick. The developer over at that company, who was like kind of the lead developer, he was one of the original contributors to the OGG video codec. And it's like even by that point it had been very like really transformed, right, since the usage. But there were like some like very original, like if you go way back through the open source repo, you would actually see some original like comments and design things and so forth from him. So it's kind of like one of those pretty neat, like that's one of those really neat people I worked with, who had like, we were in like some completely unrelated, no video at all product. I was like, oh yeah, by the way, I did this thing. And I was like, wait a minute, at that time too, especially 2009, the OGG video codec was everywhere.
Yeah.
I don't know what is
used
now,
because it was old, but
yeah. I don't know what like the leading video codec is now, because this is not a space that I've spent any time paying attention to since then. But yeah, at the time, like that was the big one, and it was this cool, like you said, it was an open source project.
Yeah. Yep. So like we didn't get to control everything about our application's install size because these codecs, they took up space, right? So we had to be very conscious about you know, the amount of graphics we wanted to put in. Like a little tutorial video did not fit because other things got too big. We had to cut back on some of our sounds and things like that. And of course, like we had these as decisions. These weren't just like, oh no, we're gonna have to cut that. Like we had it as a team. We talked about it. We said, like, you know, we can raise this up to the executive to talk to the president about if we want to increase our file size by X amount to be able to incorporate these things. But you know, it's an extra thing to think about. So yeah, yep, supporting all of that. Yeah. So, and then along those lines, talking about support, one of the things that you don't get to do always is know your logs, or, you know, any of your metrics about how often your software fails. How often do you call your operating system vendor when your stuff flakes out, right? Or even with Jonny's example, who does he call to complain about his Wi-Fi? Like who is the one that needs to know that they have a bug today for his issue? Is it even easy to understand that? And so, you know, you're not.
Jonny says me, all caps, in the background.
He's gonna complain to himself. We're gonna hear later that he's the reason why his Wi-Fi's been
I
failing.
think he is the reason why his Wi-Fi was failing, because you heard he has this dual ISV set up, and he was trying to create a like kind of way of bringing those two things together.
Fancy.
He was being fancy.
Let's say.
He was being fancy. I think what really happened, I'm gonna call you out, Jonny. I think you were trying to be fancy in a rush.
That happens.
Yeah.
And that has these results, but
it usually has these results.
But yeah, so with your errors in your system, I mean, like you can do automated you know, error collection. Every operating system has their own way of doing that. Like I'm sure you've seen it, and it'll say like send logs automatically, do this. Not everybody does that.
Oh, I don't.
Or, you know,
you don't get anything from me. Sorry, every vendor I've ever purchased a piece of software from. I'm not sending you anything. I don't have to.
I worked on software that was, you know, on drilling rigs in the middle of nowhere. They didn't have internet. They like we would think about. They had satellite connections. Data over satellite is hideously expensive. You have to be incredibly careful about, even if you are allowed to send the logs back, how much data you're sending back. You can't just like zip up all the databases. Sure, let's send everything so we can do a full forensic debrief. No,
No.
you have to be incredibly careful about all that stuff before you even get into the personalized information and all of the privacy stuff. So, collecting, retrieving error logs, getting a good sense of where your bugs actually are. Some of that just comes from, testing the heck out of your solution and just knowing that you've got a flaky library that needs some more work or something like that. But, you just really have to rely on the generosity of your users to send you those error reports, or for them to be patient when they finally break down and call you angry because they haven't been sending you error reports, but that thing that happens every Tuesday at 9 a.m. is happening again and they need it to not. And you're like, well, this is the first time we've heard of this. And like every Tuesday for the last 6 years, like, this sounds like a problem you should have told us about. We'll
5
get
years
on
ago,
it.
4 years
Yeah,
ago.
like
Yeah, but no, it
2
definitely is
months
a
in.
thing.
But so error logs, making sure that you get enough information back, because it's not like you can just go troll through every single log everywhere. Depending on the desktop application. So I worked at a fintech company at one point that was regulated by the SEC, and I was not allowed to see some of the logs.
Yeah, I was going to
Um,
say highly regulated environments in the cloud, you don't get logs.
Yeah.
Sorry, we don't get logs. We
Yeah.
get a description of the bad behavior.
Yeah.
Which, by the way, is an entire other topic of how do you write a good bug report without logs. I have a style guide. I might have to find it. I used to have a style guide, by the way, on how to write a bug report without logs.
Yeah.
And I don't know why I've never published that, because I really should, because I definitely see people don't know how to do this.
Yeah, but again, this is another one of those instances where it's totally different, but it's totally the same. It's the
Totally
same.
same.
It's just different. And that's it with so much of software. So yeah, just making sure that you're getting minimal logs can be really helpful in some cases. Yeah. What else have I written down here to mention? I think we already talked a little bit about keeping pace with operating system upgrades. That's something that can be a challenge. You do have to plan for that. Fortunately, most operating systems, and whatever else you rely on, whether it's your video codecs or any of your libraries, a lot of them these days will have regularly published cycles that you can bank on. Make a plan
Developer
for that.
previews. I
Yeah,
love the
yep,
developer preview
definitely.
option.
And so you just have to make sure that you make a plan for that, right? Back to my engineering obsessiveness with risk management. Just look historically, keep track. How long does it take for us to test a new operating system image? You can't know, right? You're not going to know. Oh God, when Windows 8.1 came out and I was working on touch devices, that was a fire on top of a fire. It was not great. Everybody that had touch devices that was, anyway, long story short, it was a horrible time.
These were the dark days.
We anticipated it was going to suck. We did not anticipate it was going to suck as much as it did. And so that was just an extra data point for us for the future. We then knew, okay, if we plan for this number of weeks of this type of testing, the regression testing on these areas, this is important, this, that, and the other thing, then, the next time we have something like that coming out, you can't predict, what's going to change in the upgrades all the time, but you can say, our worst case scenario is the testing takes this long. So if there's going to be a new operating system coming out, it's going to be pushed to the public 2 weeks before we plan to release our software suite or our application. Maybe we should bump that out a bit. Maybe we should just let people know, that it's going to be supported on this and that we will have a patch later if you're going to do patching. But in some industries, you can't. And like, we haven't even talked about if you're doing hardware and firmware and how that whole thing comes into it, and like firmware updates and like the risk of bricking your hardware. That's always fun. But yeah, planning for your operating system updates, for the patches, for your library things. Again, you do this in the cloud. You still have to do it on desktop. It's just sometimes it's a little bit more lead time,
Yeah.
but sometimes less communicative. It was, double-edged sword.
There's an example we like to use in my like internal teams a lot, which is at least when we talk about things, we are not writing firmware for pacemakers.
Yeah.
Right.
That's freeing.
That's
freeing.
So freeing. Just remember, when you think through these challenges, at least I don't write the firmware for pacemakers. By the way, major shout out to the engineers who do.
Yep.
You are like anybody who does medical devices and things that literally keep people alive. Like, unsung heroes. I'm so glad I don't have your stress levels, though. I don't, not made of stern enough stuff for that one.
I know people that work on safety of life systems, like really high accuracy GPS that lands airplanes in zero visibility, that sort of thing. And actually, it's not stressful for them because there's so much, or it's not the stress that you're imagining. It's obviously stressful, but there is so much regulation and so much testing. I had a friend who would spend 3 weeks writing documentation for every week of code that they wrote, because you had to prove that every piece of code had these ways of getting executed, that it would never be hit in these cases, that if a failure happened here, this is the execution path on how the failure would be handled. So there's in automotive as well, as much as some modern car companies, let's say, don't always follow these rules, there's a lot of regulations and certification for your medical devices to be able to sell it as a class 2 medical device or whatever else. There is a rigorous amount of testing that you have to prove that you've done internally to the company, and then it will go through external testing as well in a lot of cases. So if you want to get into doing that kind of work, that's fine. But this is, again, just another one of those choices you have to make, is you're going to have to choose to have a very long testing cycle. You're going to have to do a lot of paperwork to prove that the X or Y defect has been addressed appropriately when you do find the defects that you're going to find because it's software. So yeah, it's stressful from talking to them, but it's just differently stressful, and there are guardrails, and mistakes happen, but you do the best that you can, right? Planes don't fly themselves for a reason. They could, but they don't. We like to have that human backup, and the same thing with people. People are not the only things that are running the software. So like there's going to be backups for you as a developer to make sure there's guardrails, there's safety nets, and when stuff goes wrong, it gets investigated and fixed so it doesn't happen again. So yeah, it's I have not done safety of life work, but it's kind of funny because the people that I know that do lived vicariously through me and my highfalutin commercial software ways of releasing every 6 months. And I would live vicariously through them being able to actually document and prove that everything actually works, because it does not happen in commercial software for the most part. So
yeah, that's definitely a fair point. We all have our everything has its ups and downs, right? Pros and cons to everything. I still think it would keep me up at night, but that's because I'm somebody who worries about situations I invent in my own brain.
Yep.
So, that's who I am as a person. I think a lot of people are that way as a person. So I just that's not for me. So we're coming back. We have a little bit more than 10 minutes left, and I know we had a bunch of ideas that we shared in our planning call around
so many things
this. There are so many things that we could talk about. We ended up nerding out about hardware for a long time, I think.
Yeah.
That happens. That happens.
I think we explicitly decided not to touch hardware this time because there's so much in hardware.
And then we still got quite down the rabbit hole.
Yeah, a little bit. It happens. So just watching some of the older videos from the GitOps, the Galaxy sessions. One of the ones that I really like, just as one of that sort of it's same but it's different concept, was the I think it was episode 62, the Polaris team talking about how to actually visualize your metrics and understand all of that stuff. And just watching that and seeing all the things they were talking about, mean time to repair, or mean time to restore is often what it's called in the cloud, mean time between failures, all of those different types of metrics, those are familiar. Those are not things that you don't do in desktop applications. It's just you may get less frequent data points on that stuff, or you're only going to be able to reliably count on the stuff that you capture in your own organization. Maybe it kind of depends on the type of code you're doing. But for people that are looking at how can I improve my metrics around my test applications, because this is, I know, a very broad conversation we're having today. The Polaris tool I don't think is going to be useful for you on desktop, but they talk through all of those things. And so going through that, if you're unfamiliar with how to measure software quality, might give you some ideas. The interesting thing to me watching that was just the reminder that in my head is that a lot of these terms, mean time to failure and all of this, these these metrics, a lot of it actually comes from the electricity grid in the 50s with power blackouts and things like that. So, started off with a very analog thing, and then we're slowly building the same types of discussions around, how do we prove quality into the digital age. So, it's I find that really interesting. That again, it's electricity generation, totally different than software. Still talking about the same thing.
Still talking about the
Totally
same things.
different, totally the same.
Um,
So,
I was actually just talking about these those DevOps Dora metrics with my
yeah.
my mentee here at Red Hat just yesterday, actually.
Mhm.
And one of the things that is, they think the beauty of applying these types of things to software is that you can tune how you interpret those metrics based on what actually makes sense for what you're delivering,
Mhm.
right? So if we look at something like, I mean, I think mean time to restore, mean time to resolve is like, that's pretty straightforward, right? But one of the things I was pointing out is like, you could also add into your data collection like median and mode to that as well, though, right?
Mhm.
Because a mean is like, this is some old math knowledge from high
Yeah.
school, because that's the last time I took a math class. Right? Mean is an average, median is the middle, and mode is the most repetitive number. And like, that's actually also really important information to
Meaningful.
know,
Yeah.
right? About like downtimes and incidents and bugs and so forth. So like, if it takes me as like on a, if my average is 1 hour to restore, but my most repetitive number is 5 minutes, that's probably a low hanging fruit. There's probably a low hanging fruit in there somewhere to fix and solve or whatever. So especially if you're feeling like something's like pretty new, maybe, or it's scaled up faster than anticipated, and that surfaced a lot more issues than you've accomplished in your testing, actually starting to create new ways of looking at some of the same metrics can help you identify like your low hanging fruit for making things better, and help you identify what you might want to make better first. Because let's be honest, even though there's a concept in software quality of priority versus severity, right?
Yes.
And I actually recently saw there was an internal discussion somewhere about people were talking about whether or not we really wanted to still use priority versus severity, or just kind of like agree on a priority that like factors in severity or whatever, right? And so forth. And so the interesting thing, the difference between priority versus severity is something could completely crash your system and take hours to recover. But if there's a 1 in 1,000 chance of hitting that as an end user, and there's a 50% chance of hitting something that causes the end user to have to reload or start a workflow over, you're probably going to assign the lower severity issue a higher priority, because software quality is based on whether or not, like, what is the outcomes look like from the user perspective, the majority user perspective. What is their outcome? Is it good? Is it delightful? Right? That's software quality as a whole. And so that'll probably get the higher priority, even with the lower severity rating, compared to something that's a 1 in 1,000 or 1 in 10,000 chance of hitting. So
Sure.
I've definitely done same day patches to fix a capitalization error.
Yeah. I can see that. I
That's
mean,
absolutely happened.
So there's two things that I wanted to talk about in that is my experience with the priority severity matrix, but also the death by 1,000 paper cuts thing.
Oh yeah.
Right. So I'll start with the priority severity matrix. So I find in my experiences when I've been in companies that have used that severity impact. I've called it a few different things. You're calling it severity priority.
Severity is how bad.
Yes,
priority is
yeah.
how soon do we want it fixed.
Right. Yeah. And so what I have found is if you actually take, so what we used was 2 separate fields to track each of them, and then the whatever ticketing tracking system we were using would do the math automatically, and then we would rank things that way. But for each of the values that we would decide, we would actually put a comment in the ticket and say why it was X severity, why it was Y priority, because those things change, right? It's a 1 in 1,000 bug. It never happens, and then suddenly something updates, right? Or something changes, or the Wi-Fi gets blotchy, or whatever it is. You install it for a second time, and something didn't get cleaned up right. Now this thing is janky all over the place. So things change. Like nothing is ever stable in software, and so being able to see, we have this bug. We've had this bug for 5 years. Why did we never fix this? This looks horrible. What's happening? And then you realize, oh, okay, this only used to happen once every 12 months to one user at one place. Now we're seeing it happen to everyone. okay, and then you can just add a note. And maybe this time the severity has gone up a little bit, you're seeing it happen a little bit more, but it still hasn't reached the level where as an organization you've decided it's worth your time to fix it. um, Put in the note, and you can see that like over time this thing is happening more. Do we care to fix this before it actually becomes a problem that everybody's seeing? And if you do have the time at the end of a release or something like that, or somebody's bored on a Friday and it's a quick fix, maybe you do fix it before it actually would have been prioritized. But just having those comments there for context, and team members leave, oh yeah, Jimmy was the one that always looked at that, well, Jimmy quit 3 years ago, like those sorts of things, having that context has been really helpful.
Yeah.
So I'm a big strong advocate for having those types of data in the system, just to help make those decisions over time. But I mean, again, every situation is different in software, every team is different. Like even the Agile Manifesto, like it's not prescriptive. It's like, stuff's hard, figure it out, here's some guidelines. So I would in the work that I've done, I would struggle to find a team that wouldn't have benefited from that. But I've definitely worked on teams that refuse to use that process. So
Yeah.
sometimes change is hard.
And it's one of those things, like I talked about this in the last episode when we went over continuous integration, like as a concept.
Yeah.
And putting things into your actual ticketing systems is great, but using your CI systems to actually collect the data on these things, using your Git or other code storage, that's the best way to kind of store these decision records, because especially when you start placing them in something like that can be versioned and everything. You can also then start programmatically going back over these types of things, which, I mean, obviously this is called GitOps Guide to the Galaxy, so we know we like doing things programmatically based on Git. But so, but it doesn't have to just be operations. It can actually be you can do analysis and so forth on things that are stored. The artifact, I think that the TLDR really is that the artifact collection is one of the most important things that you can do no matter what type of software you're delivering, right?
Yep.
Artifact collection, whether that's storing, test artifacts that are required to guarantee 10 years of support, or whether that's, artifacts around failures to be able to demonstrate trends to know whether or not you need to adjust, the priority of something that has been a long known issue. That you really can't go too far with the artifact collection. I like putting it in Git. That's a personal preference. Other people don't. I understand why. The markdown language can be frustrating. Pick your poison, but collect your artifacts.
Yeah. Well, and it's not just testing artifacts either, right? Like if you're saying that you're going to support 3 versions ago of that software, that means you're going to be backporting bugs. That means you have to be able to build that software. You need to have all the licenses. You need all of that stuff nailed down. So yeah, that's super important, is artifact collection. And then just the last thing you were mentioning about fixing the capitalization issue. The one problem that can happen with that impact severity matrix is that all the low-hanging fruit are going to fall off the bottom. So I've seen that handled in a couple ways. One of them was a bug fix blitz, where go find the most annoying thing that's at the bottom of the task list, the thing that's bugged you for so long. We just have a day where everybody goes and fix something that annoys them. But also, have a death by 1,000 paper cuts user story sometimes that comes up recurring. Or maybe that's part of, in some organizations where they're still throwing testing over the wall for last minute regression testing or hardware testing. While QA is doing that, go fix the spelling mistakes, go clean that set up. Make sure that if the text at the top says, press the next button, and the button says continue, fix that. It's small, but it makes a difference, right? And so death by 1,000 paper cuts. It can sometimes be a hard sell to product managers that want fancier features, but definitely an important thing to let people do, especially because your developers are also your users. So Yep.
That's true.
Yeah.
We have processes like that here. I think most places I worked have ended up coming on some kind of process for that. I think that really is important. We are pretty much exactly top of the hour. So I feel like this is a really great place for us to cut this conversation. We hit the vast majority of our things we wanted to talk about today, and still accidentally ended up geeking out more about hardware than we intended.
And zombies. Little zombie
always.
Digression.
And the zombie digression. Man, I need to watch Last of Us. I confess I'm really bad about watching shows because I'm impatient. I only want to watch things when they're done.
Yeah, watch it and then we'll figure out when I can take you and tour you around all the sites.
Heck yes, we will. Okay.
Yeah.
That's going to be our go forward plan.
We'll do next video from Zombie Wasteland. You're welcome.
Next video from Zombie Wasteland. There we go. We'll figure that out. All right. Angela, thank you so much again for doing me the favor of coming on here and talking about really neat things. I appreciated your time today. I think our viewers did as well. I know Jonny appreciated it because he appreciates everybody. He says he does. So just confirming in the comments that Jonny says I do. It really was awesome. If we get the opportunity to have you back, I'd love to do that because I can nerd out with you for forever.
Oh, yeah, we had a lot of ideas that we cut from this. So
we did. We had a lot of ideas that we cut. There were a lot of things that did not make the cut here. So that said, it's top of the hour. Jonny, I'm going to remind everybody to choose their technical debt wisely, and then you can cut it. So just like I said, folks, we'll see you in 2 weeks. I think for cargo with acuity. If you don't know what those two things are, cargo is spelled with a K, and Christian Hernandez will be coming back and joining us. I think that's the one in 2 weeks. If I'm wrong, I'm wrong. But I think that's the one in 2 weeks. Christian Hernandez will be coming back and joining us at that time to tell us all about that. And it goes, really, we're just kind of building. This is a progressing story. You're going to see that we're actually kind of building to something. And this was our first stop along the way. So thanks again. Until then, everybody, choose your technical debt wisely. I can talk. And then we'll see you in 2 weeks. Goodbye.
Thanks, folks. Have a great day.